Hi guys, this is Miss Bogut. We're going to start our unit on probability today, and so today's lesson is really just a review of some of the vocabulary and basics about probability. So let's get started. In an experiment, we observe results, and each observation is called a trial, and each result is called an outcome. The sample space is the set of all possible outcomes. Let me say that one again. All right, the sample space is the set of all possible outcomes in an experiment. This is probably one of the most important things about probability, is to understand the sample space. So let's give an example. So let's say you're going to flip a coin. The sample space of flipping a coin, all the possible outcomes are heads or tails, and we put that in brackets. That's how we show a sample space, and you can also just write it like H or T. It's really just to help you know how many outcomes there are. The way you write it doesn't really matter. Also, think about rolling a dice. So say you're rolling a dice like you would in a board game. Well, the only outcomes that you could get on a regular six-sided die are 1, 2, 3, 4, 5, or 6. So there are 6 outcomes of our sample space. All right, now, probability. Probability is a number from 0 to 1, or we say that 0% to 100%, that tells you how likely an event is to happen. So what are your chances of something happening? That's all probability is. A probability of 0 or 0% means that the event is impossible. The event is impossible. On the opposite side, a probability of 1 means that the event is certain. It is definitely going to happen. It is certain. And this next sentence is also really important. It says the probabilities of all outcomes in the sample space add up to 1, or 100%. Same thing. So for example, if we look at the sample space of flipping a coin, we know that the probability, just from our previous knowledge, we know that the probability of getting heads is 50%, and so is the probability of getting tails. So when we add up all the probabilities of all the outcomes in the sample space, we get 50% plus 50% is 100%. Let's try some examples. The probability of an event can be written as P and then parentheses, and then you describe the event inside the parentheses. Again, just like the sample space, when you describe the event, that's just for you. It's not really a right or wrong description. The numbers will still be the same. So let's look at this first example. It says the weather forecast shows a 30% chance of snow. Give the probability of each outcome. Well, the outcomes are you're either going to have snow or you're going to have no snow. Obviously, there's other forms of precipitation, but in this example, we're just talking about whether or not we get snow. So we would describe this as the probability of getting snow. And this actually tells us in the word problem that there's a 30% chance of snow. So it gives us that probability. However, on the opposite side, when we're talking about no snow, the probability of getting no snow, we can use that rule that we learned, that all of the probabilities of all the outcomes in the sample space of snow and no snow should add up to 1 or 100%. So that means if the probability of getting snow is 30%, that means that the probability of no snow is 70%. So 30 plus 70 is 100%. Let's look at this example B. So in example B, we're given a little spinner. And the spinner has 2 red sections, 1 yellow and 1 blue. So that means that the possible outcomes, if you were to spin this, you could land on red, on yellow, or on blue. So for instance, if we're talking about the probability of this event, of this outcome, we could just say P of R, which for this case, R stands for red. Well, we know, looking at this spinner, that there are 2 sections that are red out of 4 total, and that's really the same thing as 1/2, and we know that 1/2 is 50%. So the probability of getting yellow, we can do similarly. So in this case, there's 1 section out of the 4 that are yellow, and I know that 1/4 or 1/4 is 25%. Also with blue, the probability of getting a blue when you spin is also 1 section out of 4, or 25% again. Now, just to make sure, just like we did with our snow example, 50 plus 25 is 75, plus another 25 is 100. So let's just write that out to the side. So let's just make sure every time you take care of everything, make sure that you've added everything up and that you get 100%. Perfect. All right, let's go on to a couple more examples. All right, now in this example, we're given a little chart, and this is probably something like Pizza Hut or Little Caesars, something like that they would put together, and they would say that the number of toppings is anywhere from 0, which is your cheese pizza, to 5, which is your supreme. And here our probabilities are written as decimals, so when we add them up, they really should add up to equal 1. So let's just try that. I would just use some extra space down at the bottom. So here I would say 0.205, 0.305, 0.210, 0.155, 0.123, and finally 0.002. Remember that when you're adding decimals, you always line them up. 5 is 10, plus 5 is 15, 18, 20. So we do this and carry the 2. 2, 3, 8, 10, 0. We put the 0 down, we carry the 1. 1, 3, 6, 8, 9, 10. The 0, we bring that decimal, we add that 1, and we're left with 1.00. So good news, our probabilities all add up to 1. Now, in this first problem, it asks, what is the probability that at least, I'm going to highlight that, at least 2 toppings are ordered. So I'm going to write probability, and then I'm just going to quickly write at least 2. All right. Now I'm going to use my highlighter and highlight and say at least 2. Well, that includes the probability of getting 2 toppings, 3 toppings, 4, or 5. These are all at least 2. So when I add, or when I get my probability, I can actually add each of these probabilities of getting 2, 3, 4, or 5. So I'm just going to add all of those up. Plus 0.155 plus 0.123 plus 0.002. All right, and then I'm going to write this equal sign down here, and I'm going to do my math up here. 0.210, 0.155, 0.123, and 0.002. I'm going to add all those up. 5 and 3 is 8, plus 2 is 10. 1, 2, 7, 9. 2, 3, 4. And I bring that decimal down. So the probability of ordering at least 2 toppings is 0.49, or as a percent, hope you know this, is 49%. If you don't understand this, you definitely need to come see me. All right, also, let's just go ahead and highlight right here so we know that this is A. All right, now let's go on to B. B says, what is the probability that fewer than 3 toppings are ordered? And that's another key phrase. Fewer than 3. Well, 0 is fewer than 3, 1 is fewer than 3, and 2 is fewer than 3. 3, though, is not fewer than 3. It's equal to 3. So we're not going to include 3. We're just going to do 0, 1, and 2. Those are all less than 3. So when we go ahead and we're going to always write the P and then describe the event, this is really important just to organize your thoughts. Always want to write this: fewer than 3. Then we're going to add them up. We're going to add up 0.205, 0.305, and 0.210. We're going to write our equal sign, and we're going to do our math out to the side. 205, 305, and 210. Make sure you're doing this math. 5 and 5 is 10. 1 and 1 is 2. 2 and 3 is 5, plus 2 is 7.72, or 72%. So that's your percent chance of ordering fewer than 3 toppings. All right, that's it for the notes for today. So make sure that you have everything copied down, including all this math out here to the side. Make sure you've all got it written down. Ask some questions if you have any questions about things, and then get ready to do your assignment. Thanks so much, and I hope you have a great day today.